We'll do an example on how to find infinite limits numerically, meaning using a table of values. So let's consider the function g of x equals to x squared divided by x minus 1. This is the rational functions. And then we can see that we can find a vertical asymptote. The vertical asymptote of these functions is x equals to 1. Okay, because when x equals to 1, the function is undefined. So then it has a vertical asymptote, x equals to 1. And as a reminder, at vertical asymptotes, your function will, the limits of the function will either go up to positive infinity or down to the negative infinity. In some cases, both sides of a function can either go up to positive infinity or down to the negative infinity. Okay, but anyway, at a vertical asymptote, you will have infinite limits when x goes to the vertical asymptotes. All right, so the question is, what is the limit of the function g of x when x goes to 1 from the left side, right? Okay. And again, this is a case when we don't have an access to a graph of the functions. So then we have to create a table of value and want to figure the functions, the limit of the function goes to the left of 1. So then we have the table of x values start with 1, and we know that f of 1 is undefined. And then we find a few values of x on the left of 1. So 0.9 is close to 1. But if you want to get a little closer, 0.99 or again 0.999. Then we find the function values at x equals to 0.9 is negative 8.1. If you go a little closer, you get negative 98.01. A little closer, you get negative 998.001. So then you will observe the behavior of the function at x goes to 1 from the left side. So you start at the negative value, negative 0.8, goes down and down. This is not a good way to graph it. So it's like dramatic down. And it keeps going down to negative infinity. We know that when x goes to 0, x goes to 1, and 1 is a vertical asymptote, you have either negative infinity as the limit or positive infinity as the limit. So then after creating a table of values, you observe the patterns of f of x as x goes to 1 from the left. You see that it's going down and down and down, right? Dramatically, it drops dramatically from negative 8 to negative 98 to negative almost 1,000. So we know that the limit of the function when x goes to 1 from the left side is negative infinity. Now, how about the limit of g of x when x go to 1 from the right side? Of 1. Again, we want to create a table of values. We start with 1. We know that f of 1 is undefined. And then we find some value of x on the right side of 1. So 1.1 is pretty close to 1. We want to go a little closer, 1.01, and closer, 1.001. And then we find the function value f of x. So we start with 12.1. And then we go a little closer, we increase the function value increase to 102. And we go a little closer, the function values increases to 1,002. So if we observe the pattern of the function's values at x goes to 1 from the right side, you see that it starts from 12, increase and increase. So you can see that the function will keep increasing until, up to positive infinity. That means the limit of the functions when x goes to 1 from the right side is going to be positive infinity. So we just found infinite limits of a functions at vertical asymptotes using numerical method or using a table of values.